Hello everyone, and I guess I'll continue with the text to SQL project from where I left last time. Just as a quick recap, the version V1 of the app um, took in three inputs: the question, tables and columns, and the dialect from the user, which is then passed as a query to the LLM, which generates the SQL code. Now this was the code. So we had a simple prompt here, the dialect, the schema, which is basically the tables and the columns um, that the user felt was the right one, had to be fed into the LLM along with the question. So let's say for this particular question, um, it generates a certain code. Looks good. But the problem with this is that the user has to always feed in the necessary tables and the columns, which can be a hard task, considering there could be multiple tables and columns. So what I did was offloaded this particular um, step and passed it on directly to the query. So what I did was I created a schema consisting of all the tables and the columns into a variable and imported this into the prompt, uh, and everything else remains the same. Um, so if I run this, it has to give me the same output. So in a way, we reduce the workload on the user by giving in the schema, by injecting the schema directly into the prompt. But the problem with this is the model does not have enough context about the columns or the values, right? In this particular example, there is actually no customer state called as Minas Gerais. In fact, it is present in the data as MG, right? So this is something that the model does not know, um, and that was like the main drawback with this version V2. And of course the other problem is that as the schema builds up, right, the entire schema was being fed into the app, which means it is using more tokens and increased cost therefore. um, so that's when I moved to version 3 of this app. So what I did was I converted this tables and columns into a knowledge base. So basically it's the same but enriched with some more information. And I'll explain how this works, right? So what happens is I have the raw table descriptions, and this is from the data that Kaggle provided themselves, right? Some raw table descriptions, some similar to this. Customer data says it's customer identity locations and so on. This is a shortened version though, but the one on Kaggle is slightly longer. So those are the table descriptions. So that goes into the LLM, and at random, 5 records from each table is fed into the LLM from the database, and this goes as a loop, right? Now comparing the table descriptions and the columns, it then generates the knowledge base. So we are making use of an LLM here, and this knowledge base consists of updated table descriptions. So this was the initial table description. The updated table description contains more concise and informative descriptions. It also has column descriptions for each column and some sample values, right? So if it is a number or if it is a unique ID, string, so on, it has some sample values. um, so this goes as a loop, and we have like an enriched version of the knowledge base. Now going to the script, I have like a KB builder Python file. So I'll quickly walk through this. I'll not go in detail, but to start with, I have the table descriptions here. Let's say the customer data set has this detail, geolocation, and just a one-liner about it, right? Yeah. So the next step would be to fetch the samples. At random, we are selecting 5 samples from each table, and this is again based on the SQL Alchemist engine, which helps us connect to the database. Next would be the LangGraph model. So what this basically does is, let's go here first. Um, the state graph, we have only one node, which is to annotate. So the start passes through the annotate to end. If I have to show it, um, right? This is basically the LLM, which is the annotation node. You have the start and you have the end um, edges. So what this annotate step does is, of course, we have the template here. So it says you are a skilled data annotator. Your task is to generate precise, detailed descriptions of SQL tables and their columns and so on. The human provides some instructions here, and the output has to be in this format, right? Table description followed by the column and its respective description, along with some sample values. I think I mentioned one or two sample values for each of them. So this is the prompt for this. Um, so the two variables here is, of course, the description, which is this, and the sample value. So those are like the two variables that goes into the prompt. This is then executed by the LangGraph node. Um, yeah, right. And of course the main function is this one, which then loops for the number of tables that is present in the DB, and each time it selects five random records from each table, passes it to the LLM. The LLM then compares it with the table descriptions along with the column data to generate updated table descriptions, column descriptions, and sample values. So this is how an enriched or like a knowledge base would look like, right? It's a dictionary. It has the table name, table description, and column name, column description, and sample values, and so on for all the values, right? And similarly for the other tables. So now this looks like an enriched version, right? Earlier we had this schema, basically just the table name and columns, but now I have more information, and that's why I've called this, oops, and that's why I've called this the knowledge base. So otherwise the workflow is entirely the same. Here I had like basic tables and columns. Here I have the knowledge base. And if you look at the script as well, it's pretty much the same. Um, I'm loading the knowledge base. Um, kb.json is the knowledge base, right? So I'm loading it and storing it into a variable called kb, and that is the one that I'm feeding it into the schema. If you look at the previous script, it says schema, but here it would be the knowledge base, and everything else remains the same. And now if I run this version v3 of the model, this should accurately give me the customer state as mg. And if I run this into the database, this would accurately give me the count, because earlier when I said the actual name of the state, it didn't run, right? So that's how that's how we have improved from the version v2 of the model. But having said that, this again has some drawbacks. For this, we'll go into langsmith and look at the last three runs. So uh, let me see if I have the latest runs. Yeah, there you go. So this was the version v3 of the model, right? Um, so it has all the schema along with the necessary column names, sample values, and so on. And the reason it was able to, let me show you. The reason it was able to accurately find this mg is, if I go into the JSON file for this particular customer state, it has the sample values shown this way. So LLM is powerful enough to identify that this is how the values are, and the state has to be mg rather than the actual state that was fed into the input. But coming to the runs, right, in Langsmith. Of course, we have the entire schema fed into this, but comparing the third version, second version, and the first version, we can see how the latency is still the highest, because now the schema has gotten even bigger, right? It has more knowledge, but the schema has just gotten bigger, and this is evident from the token usage. When we went from V1 to V2, we said how the token usage had like doubled or tripled, but now it has got uh, bigger or larger by what, almost 20 times. And that's because, of course, it has gotten bigger in terms of the descriptions, the sample values, and so on. So now this will again have an implication on the cost that is associated, which is also why the latency is higher. So, in terms of speaking about the token usage or the cost, the absolute lowest was the version V1. So, while we improved in terms of the quality of the code generated or the user's input, um, like the heavy loading on the user, version 3 is better, right? But the reason version V1 was lesser in terms of token usage or the cost is because in the tables and columns detail, we fed in only the specific table or the columns associated which was necessary for the query. But at the moment, we are feeding in all the data, right? And this is ideally the next step in the app, to maybe have an LLM like a router to help us identify which specific columns are related to the query, and only filter the knowledge base based on them. That way we can reduce the kind of token usage. uh, and yeah, so that's probably what I think I'll work on next. But if having followed along all this way, I would appreciate any constructive feedback, any ways I can optimize this code and so on. But yeah, thank you so much.